Good. This is the last of the 4 lectures. Initial title of it was Parametric Design and Robotics, and Fabrication, rather. And now, I changed the emphasis of this last lecture a little bit because I realized that the group which is taking the seminar is diving deeply into fabrication. So I didn't want to repeat the things you might know much better than I do. And so I will skim over fabrication very quickly during the course of this lecture. But I will more focus on the relationship between the two. So basically we will kind of recapitulate the issue of parametric design and fabrication, but dwell a little bit more on adaptive architecture and dynamics in architecture, as well as biorobotics, which is a new kind of orientation emerging in recent architectural undertakings. So I also will supplement some of the issues I talked about in last lecture. I couldn't plug them in. There was no room, or I was not ready with those arguments. So I think that one could reflect on this importance of geometry as a foundation of these architectural pursuits. And I documented in a previous lecture talking about Euclid and Descartes, and I started with this drawing to remember that this is a drawing of York Utzon for the competition in 1958 for Sydney Opera House, where he set up the concept based on this rigorous geometry. And one could almost use it as a caption for the famous line of Louis Kahn, another contemporary modernist American architect, who proposed that for in architecture, geometry is mother of invention. So it's kind of elegant way to connect this culture of geometry and long tradition history to computer graphics, which is actually continuing. The notion of parametrics in architecture has been around, but actually the Italian modernist architect Luigi Moretti really can claim authorship of it. He coined it in 50s in 40s, even before the war, in his writings, and he sort of encouraged in his research link to modern mathematics, and his premise was that a new architecture will be labeled, he proposed will be labeled parametric architecture, and will be derived from absolute mathematical truth, independent of other factors. So Moretti, a goal of architecture systems was defining the relationship between dimension dependent upon various parameters. He used design of a stadion as an example how its form can be derived from various parameters like cone of vision and seating arrangement and things like that, and acoustics. So the versions of the parametric stadium designed by Moretti there were different versions were presented at his parametric architecture exhibition on Milano Triennale in 1960s. So while he was attracted to the logic of mathematics and geometry, he also was a very, very strong design-oriented architect, and he believed that art and architecture can never exist out of realm of senses, and placed great emphasis on intuition, instinct, and feeling. This was very much very talented modern architect in Italy. He's not very exposed in the literature because he had a little kind of incident. As a young person, he was a follower of Mussolini and did few buildings for him, and he paid dearly for it later. He wasn't very much accepted, but he definitely man of great talent and credited with those parametrics. But real shift in architecture, which began with development of computer graphics, and that's 60s, and that's Sutherland, which I mentioned last time, where each, in his proposal, each constraint has a set of input variables, and in the diagram on the left shows his first 6 atomic constraints of his program called Sketchpad, and each constraint had precise algorithm attached to it, and using light pen, designer could draw things obvious like to us today, like lines, arcs, and parallel offsets and stuff like that. He never used the word parametric in writing those constraints, but all the essential properties of parametric equations were there. He really can claim authorship of this first parametric modeling system, which is called Sketchpad. Also in 60s, the important step was architectural design, published in 69, which was devoted to interaction and digital computation in architecture, very experimental work. Articles by Negroponte, Cedric Price, and Gordon Pask, who introduced the idea that architects are first and foremost system designers who have been forced to take increasing interest in organizational system properties of development, communication, and control. Architecture, Pask argued, had no theory to cope with pressing complexities of the time, and it was only through cybernetics understanding of systemic processes that this discipline could evolve. Central to his arguments was understanding of the pursuit of the concept of communication control, but he also was important to propagate the idea of architecture as a living and evolving system. So their early experiments were analog; they were not digital, but addressed significance of parameters dealing with observer in order to understand tendency of the attribute of lifelike properties to a simple interaction. The installations they proposed, the mobiles they proposed were composed of light, sound, and rotating elements, and they claimed to converse with the machines. Now, this was those were the people who were involved in Archigram, which you know, and one of their sort of pilot projects, of course never built, was Fan Palace, that would operate as a time-based architectural machine, and which was to evolve through everyday use. And you see the aesthetic, at this time it was revolutionary, which belonged more to the factory than to architectural edifice. And you see the elements like prefabricated elements, which are kinetic and movable sidewalks and stuff like that, space frames. And here is another aspect of the Fan Palace project, and this has a very sort of surprising relationship to the building which you know well, which is Pompidou Center in Paris, which was then competition won by who is that famous Renzo Piano, by Renzo Piano as a young architect about 5 or 6 years later. and use of space frame and use of aesthetic of change and sort of high-tech industrial aesthetic was very much proposed by those groups of people. So computing on one hand, and then this kind of stuff. Now the space frames I mentioned were really developed through very rigorous use of mathematical modeling by Bucky Fuller, and here are a few of his domes. The space frames and geodesic domes which he developed were used extensively by American military in the 50s during the Cold War, and that's maybe one of the reasons why they never took off in the marketplace, because they monopolized it. But Bucky's work was fundamental, and today in physics, as of last 15 years, we have a kind of carbon discovers carbon structure of carbon molecules, which physicists call Fullertons, to commemorate his geometries and his discoveries and his analysis. Another person which I pursued this issue of space frames and was very original with his work was Alexander Graham Bell. This is earlier than Fuller, and also different kind of aspects. You know him because he invented telephone, right? An American and later Canadian inventor. So he patented a space frame type of structure early on and used it for the kites and his flying machines, which were largely unsuccessful, but telephone was much more successful, of course. Those were frames which were rigid, and well, they could be flew, but they were rigid. So I want to talk a little bit digression to this, starting with this famous detail of Johann von Goethe. He called architecture frozen music. So I think we need to reflect on that a little bit more, because architecture is an equilibrium of forces, and statics are central to it. But kinetics, which is study of motion, is also admitted now to architecture. And term of kinetics, which relates to the classical mechanics, is concerned with the relationship between motion of bodies and its causes. So today, kinetics is substituted in general kind of engineering by dynamics, and that in turn brings us to the study of motion. And this has to be credited with Edward Muybridge, first photographic studies of motion and early motion picture projections. They were instrumental in developing that, and also I think a little bit earlier work of Jules Marie, a French inventor, who published volume analyzing the flight of birds, Le vol des oiseaux, illustrated with photographs and diagrams. And some of the diagrams you see on the left-hand side of the screen. His work had significant impact on the research of Edison, as well as Lumiere brothers, who of course advanced film a lot. So his research was awakened also interest of painters and artists in a notion of motion. So that leads us to Cubists and Futurists, and you can see the painting of famous painting of Marcel Duchamp. Was clearly inspired by studies of this Jules Marie. The painting is called Nude Descending Stairs. You know it well. So today why motion is so important, why it's coming back to us, and why this interest with nature.
So what would be better to use the herring gull in its freedom, circling and swooping over the sea, and use this as a role model? So we bring a team together. There are generalists and also specialists in the field of aerodynamics, in the field of building gliders, and the task was to build an ultralight indoor flying model that is able to fly over your heads, so be careful later on. And this was one issue, to build it that lightweight that no one would be hurt if it fell down. So why do we all this? We are a company in the field of automation, and we'd like to do very lightweight structures because that's energy efficient, and we'd like to learn more about pneumatics and airflow phenomena. So I now would like to take your seatbelts on and you put your hats off. So maybe we try it once to fly SmartBird. Thank you. So we can now look at the SmartBird. So here is one without a skin. We have a wingspan of about 2 meters. The length is 1 meter and 6, and the weight, it is only 450 grams. And it is all out of carbon fiber. In the middle, we have a motor, and we also have a gear in it, and we use the gear to transfer the circulation of the motor. So within the motor, we have 3 Hall sensors that we know exactly where the wing is. And if we now beat up and down, we have the possibility to fly like a bird. So if you go down, you have the large area of propulsion, and if you go up, the wings are not that large, and it is easier to get up. So the next thing we did, or the challenges we did, was to coordinate this movement. We have to turn it, go up and go down. We have a split wing. With the split wing, we get the lift at the upper wing, and we get the propulsion at the lower wing. Also, we see how we measure the aerodynamic efficiency. We had knowledge about the electromechanical efficiency, and then we can calculate the aerodynamic efficiency. So therefore, it rises up from passive torsion to active torsion from 30% up to 80%. Next thing we have to do, we have to control and regulate the whole structure. Only if you control and regulate it, you will get that aerodynamic efficiency. So
I think it was interesting for those who don't know this project. I think this pursuit of analogy to nature is also important in some of those engineering projects, and also important in our discipline. So that brings me a little bit back to the concept which you probably know from your history of architecture, the concept of metabolism That's a group of Japanese architects. Among them, key person was Kikutake in this group. And the notion of metabolism stands for transformation of cells of living organism, which allows our growth and reproduction in response to the environmental conditions. So Kikutake metabolism proposals were somewhat utopian, but they were distinguished by his understanding that understanding of the city as a generative process that works in a cyclical fashion and has a potential to further define and evolve the urban system itself. Its three critical principles were the investigation of alternative environments, adaptability of the city and housing unit which had to be capable of being replaced as required, and the conception of architecture as ecological entities with life cycles that could be renewed in response to the environment. So those early schemes proposed continuing metabolical transformation of the urban tissue, and their architecture was actually related to that. This was demonstrated by his projects titled Ocean City, where living units could be replaced and the city could be transformed as through a process of continuous reassembly and refabrication. Interesting to observe as a sidetrack that one of the Kikutake's star students was Toyo Ito, who later became contemporary leading architect. So it's kind of connected, this culture. Of course, this was all before computing. In UK, at AA, there was a group of students and teachers, young teachers around John Fraser. This unit was particularly active in 90s, early 90s, and they explored the use of early computer techniques to empower idea of evolutionary architecture. So it was a kind of form of metabolism, but there was also attempts to use generative tools, early CAD tools, to model and develop schematic projects which explore this concept of evolutionary architecture. They publish their work under the title Universal Constructor, with a model which was a series of individual cells representing structure of environment, and each contain integrated circuit which communicate with the units next to each other. This in itself is well published. The corpus of work, I haven't dwelled into it because we might not have a time, but it's interesting for you if you want to get farther into it. It is early 90s. Among the projects which have been realized early on was a hothouse or greenhouse in botanical garden in Denmark, nearest Aarhus, and their structure was based on result of optimization and programming. This envelope was made out of double layer ETFE cushion, and it was responding to the pressure, the nature of those cushions. One level was printed and another was printed in a different way. So when the pressure was differentiated, transparency of the envelope was changed. So this was kind of interesting, not only through the structural system, but also by the nature of the material, which was responsive to the characteristic of material was changing depending on the condition. There were optimization techniques which I will not go into maybe but I want to go to make a reference that those techniques are to some extent inspired by natural strategies for optimization, because it is well known to the people who study natural sciences that those processes have always been source of information, inspiration to science. It was organism which are single cell, like bacteria, can often engage in rich of repertoire of interaction and resolve into kind of system which is active. Now, the introduction of the modeling, particularly 3D printing tools, at early stage they were still kind of pricey, so the only big units could have access to it. And Norman Foster office had a kind of part of the office devoted to they call specialist modeling group devoted to this problem, and they explored this new geometrical territory through use of programming and parametric software. This was way before Grasshopper came about, so it was hard coding. But studies explore mathematical concept of inversion principle and suggested possible relevance of it to architecture and to kind of adaptive structural and cladding components. This is a kind of assembly of their exploration, where algorithmic concepts were in a form of sketching and brainstorming to generate an idea for development and design. That was coming out of Foster's office. But returning back to the current condition, I think it should be recognized. We should recognize the work of Andrew Payne and Johnson, who brought in about 6-8 years ago. They developed Firefly, which is plugin for Grasshopper, known to you, which extends geometric control beyond virtual parametric model to real world of machine and mechanisms. So the Firefly plug enables communication to flow in other direction, allowing virtual building models to be informed by and interface with from data from reality. So that was a very important step for parametric design to start being fed with environmental factors. This was very important tool, and it's still in existence and developed. I think we use it in our robot studio. Few projects which emerged relying on the dynamics was kinematic facade of Ocean Pavilion for the 2012 Expo in Korea. I think you know this project well. This was winner of the competition and had this fish-like fins, which was de facto kinetic facade that was made out of fiber reinforced plastics and was capable of being morphed into a number of animated patterns depending on the program requirements. This work in terms of programming technology was done at the University of Stuttgart, where those biologically inspired motion mechanisms were brought to architectural scale. Today we see dynamics and kinetics in architecture frequently. This is a recent work of Henning Larsen, Danish architect, building in campus in Denmark, and the reasonably simple hinged elements or shutters still somewhat perforated according to the requirements. I think simple solution, but it's working. And he proposed, I think this building was recognized in Denmark because of its energy kind of footprint. I think it was one of the most green buildings 2 years ago or something like that. Those new techniques, they require, of course, a closely related and product of fabrication methods, and they are related to parametric design. There's a relationship of fabrication to parametric design. Digital instruments and practices have potential to narrow the gap between representation and between design and making. Its essence is ability to generate construction information directly from design information. That is why people predict new role for architect as that of digital craftsman. Lisa Iwamoto, who is teacher in the US, young teacher at the time, wrote a book where she tried to organize different types of fabrication techniques. And this is, she proposed 5 types: sectioning, tessellation, folding, contouring, and forming. This is arbitrary structure, and I think you can devise your own, but the type of design emerging with using each of those techniques has its own characteristics. So sectioning, where the things are, where 3-dimensional model is bisected, layered. Ask the Box, the project which we done here, or Professor Swick students done here a few years ago, was exactly that. It was sectioning. Another methodology for fabrication is tessellation, where the object is tessellated and then flat elements are produced with CNC and assembled. They are closely related to to the method of designing. Method of production has become related to the method of designing. Concept of folding as a production of the object also is kind of obvious. Another group of categories of fabrication she sees as contouring. This is done with CNC by removing the material. And final category was forming, where things are cast. Extending this concept of new condition for design, triggered by initially CAD and then parametric design, algorithmic design and fabrication. This impact of it is now entering public domain. I want you to take a look at the work of Mei-Jin Yoon, who is now young professor at MIT. And she proposed that while architecture was traditionally defined the limits between public and private, the public realm is not merely a byproduct of architecture and urbanism. It is actively constructed physical, political, and social space where parameters are constantly being renegotiated. So performative architecture in the public realm seek to create environment that call attention to this negotiated status, engaging in public interactive scenarios, responsive context, and constructed agencies. This is a project which we'll see in a minute in some detail, I guess, which is interactive installation form of the ceiling, I guess, suspended ceiling, which was where photovoltaic panels were gathering lights and lithium batteries charged to also generate LED lighting. And the process of making of it and assembling it was important to her. I would like you to look at fragment of her lecture, which is not that all year old. I think it is interesting.
So there's really nothing I dislike more than public speaking, and that's odd for someone who's so invested in the public sphere and the public realm. I'm trained as an architect, so I'm used to building walls and separating myself from the public. One of the things that has fascinated me is this kind of sometimes invisible line between public and private. This is a piece by Vito Acconci called Following, in which he has a very simple set of rules for this performative practice where he decides to follow someone in public space, and as soon as that person goes into a private space, he waits until he sees another person and follows them in public space, and so on and so on. And by engaging in this itinerary, he actually remaps the city, and he remaps the city based on a series of individuals' experiences of publicness within the urban context. So, I don't know, 15 years ago, I arrived at MIT, very uncomfortable because my background is not in technology. I went to pretty traditional architecture schools, and when I arrived at MIT, I was very anxious. So the first thing I did was I decided I should take a course, even though I was a faculty member. So my first semester as an assistant professor, I took a course. It was called How to Make Almost Anything. So I took this course. It's at the Media Lab, taught by Neil Gershenfeld, and it's a crash course in microcontrollers and fabrication. And the final project I made for that course was the defensible dress. So now you can get a sense of my aversion to publicness, and how private I am, and how important it is for me to defend my personal space. And what's interesting is personal space is very cultural, not only is it very cultural, but the ways we define personal space and public space are very nuanced. This one isn't so nuanced. The defensible dress was made out of shape memory alloys, a microcontroller, and a sensor, and it found its way into the LA MoCA as a design project. So one of the things I think is important about creating a truly engaging public space is you have to create something that is unfamiliar. You need to defamiliarize context such that the rules of engagement are less clear. Many years ago, a decade ago actually, for the Athens Olympics, they had an international design competition to create sound and light installations around the city. And for me, the project was an opportunity to create a new urban public space that would respond to people as they move through the field. The idea was that the public would in fact choreograph that field. This has sound. And the lights would respond to their movement and create a kind of wake behind them as they move through that field. And the idea of whiteness was based on this notion of accumulation. So white light, white noise being all the audible frequencies within the range of human hearing. And that was the kind of beautiful impression I had of what the piece would be like, but in fact it was much more like the image you just saw. It was so crowded that you couldn't get a sense of the flicker of the lights as people moved through it, and then the fading away. And that was the first lesson for me about public space, that once you put it out, once you go public, you don't know what will happen, and you can't really predict people's behaviors. And what was interesting about the piece was that everyone wanted to break it, and they wanted to break it in order to figure out essentially how it worked, which was interesting. So, a decade ago, custom microcontroller, cheap speaker, these were mounted underneath a raised deck. But what was interesting was that people would invent ways to inhabit it. We saw people invent games within the field, and people would just love to hang out in that space. So I mentioned the kind of notion of cultural difference about personal space, and I think this notion of difference is part of my work. This is from Rudofsky's book. He's famous for writing a book called Architecture Without Architects. But this illustration, he's comparing a Japanese garment, a kimono, with a Western garment. And on the left, he demonstrates that the cultural bias is towards a kind of efficiency and no waste in terms of the use of material. And so the kimono is really based on the linearity of the bolt of fabric, and size and curvature is taken up by things like the fold, whereas the Western garment, which privileges the contours of the body, leaves these kind of residual pieces of the garment. And so I wanted to kind of synthesize these two ideas and create a garment, and this is the Mobius dress, and essentially it is a literal Mobius strip that's turned into a wearable garment. And the idea is to combine both the curvature of the Western garment and the efficiency of the kimono, and to create a very, very long linear Mobius strip with a super long custom zipper, so that it can essentially be, this Mobius strip can be worn, essentially to be unworn, and as it unravels, the body structures the form of the garment in different ways. So in terms of responsiveness, I think that architecture has a way of creating relationships between content and context in the public sphere. Also, about a decade ago, I was asked to do an exhibition, and this was what was given to me. It was a itemized spreadsheet of about 400 Aztec artifacts, and the curator wanted to display these objects in the Guggenheim Museum. And the first thing I learned was that the Guggenheim Museum was too small, that because of the geometry of the Guggenheim along the ramps, there wasn't going to be enough surface area to accommodate all these artifacts. So the design idea became about creating surplus surface. And in order to do that, there was a very simple formula of undulating in and out a wall. And all of those objects had certain criteria associated with them depending on which lending institution they came from. So certain objects needed to be behind glass, others didn't have to be. There were issues of scale. And so it was the first time where I designed something via a spreadsheet. Essentially, what we did was create these pocket parameters where every artifact was essentially tagged with the way that the wall needed to behave that housed it around it to create a mediation, essentially, between housing the artifact and the context of the Guggenheim and its ramps. And it became a really useful design tool and visualization tool to move back and forth with the curator, who constantly changed the sequence and order of these artifacts until the very last minute. And the wall is clad in half-inch thick felt, and the other thing it did to transform this public space was it absorbed not only light, but sound. So it created this deep, dark, mute envelope, and I guess you can tell because this is actually a very live space, but acoustics affects how you understand public space. And so here at the Guggenheim, for the first time, this kind of deadening silence instead of the live bouncing of noise altered your tempo, your perception of the artifacts. And here you can see every object is on its own custom size, perfect pocket or shelf, and then they're smoothed out together. And when you get to the top, what I did was I pulled in the wall so that you would go up on one side, and then when you come down, because that's the most annoying thing about the Guggenheim, you have to go up the 5th floor ramp to the 6th floor and then backtrack. And so I wanted to actually help Frank Lloyd Wright complete his loop. So essentially, you come up the backside, you see all the large artifacts that didn't fit in the system, and then you come back down on this side. And when you come back down on the other side, these are the environmental vitrines for the really precious artifacts. And in order to see them, you essentially have to get right up against that felt wall. And this is the view looking down. So this notion of responsiveness to context, I think, also refers to the environment as well. I was asked to do a public space project in Phoenix, and it seemed that the only way to create public space outdoors in Phoenix was essentially to create shade. So the project became about creating shade through this notion of a public parasol. I'm, as you saw earlier, fascinated by Mobius strips, and so essentially the unit for this shade device was a Mobius strip, a very efficient strip. But what was important about the geometry was that in certain angles, it would cast a shadow to create shade, and in other angles, it would frame light through a shadow. So the project is called Shadow Play, and it clusters these Mobius strips together to create this public parasol. The public space is in a traffic island, and a triangular traffic island. And what was really important was to understand the relationship of the shade and shadow based on different months of the year, depending on the solar angle, and to make sure in the hottest moments there was maximum shade, But in other parts of the day, morning and evening, there were opportunities actually to see the sky, to create ventilation, and to cast these dappled light shadows. And what also became really important was how to minimize the amount of material to create this shade. So these are a series of different iterations that look at the geometry and the structure of that geometry and how much material it would take. So these are different deflections of different geometric iterations of those units. And you can see that depending on the geometry, they torque and twist and deflect in different ways. And through these studies, we were able to reduce the amount of material by, I think, 20 tons, which was quite substantial and reduce both cost and material use. So it's super thin, almost feels paper thin. It's currently under construction and it should be done in a few days, weeks. Sorry, I said days, weeks. I wish it were done in a few days. But the top of this canopy has solar panels, and so at night, it emits the light. I think the other thing about public projects is they make visible things that maybe are people are less aware of. And so this is part of an environmental series. This one's called Windscreen. And with very, very cheap materials, I think all of these things cost, if you add them together, $2.50. To create a micro wind turbine and to affix it to a building at MIT that is notorious for its wind. It's called the Green Building, because the wind's coming across the river and then it goes up this tower and then back down. So in the portico, we hung these small windscreens for MIT's 150th anniversary. And the idea was just simply to make visible this natural, abundant, renewable resource that's around us all the time. And basically the speed of the wind, the angles of the wind, is generating the light quite literally through the kind of mechanical movement of the turbine. Nothing's stored, it's just purely made visible. And this idea of making something visible in order to mediate is something that's interested me in the architectural work as well. And so a few years ago, had an opportunity to design a space for the Boston Society of Architects. They had a competition because they were moving from a very vertical building to adaptive reuse building in which they were getting a large square footage on the second floor of the building. The BSA has a kind of notorious old boy reputation, insular, and so this became an opportunity, I thought, in the competition to really celebrate it as a public space. And so part of the program brief was it had 20,000 square feet of space, but 5,000 square feet was dedicated to public gallery. So for the competition, what we thought was important to do was, given it's on the second floor, be very strategic about it. So how do you get someone to pay attention and know something might be accessible in public on a second floor? So we gave it this bright green ceiling. And then the key was really, how do you scoop people up to get them to that second floor? So we wanted to create a super figure that extended beyond each of those kinds of windows, something unusual that would draw people in. And then what we did was we pushed all the office spaces and administrative spaces towards the back and put the conference rooms interspersed in the middle as islands in order to essentially create a mixing chamber between the architects, the students, and the public, but fundamentally to give up all of the perimeter to the public gallery space. So this was a risk in the competition because they didn't ask for that much gallery, and we turned the whole thing into public gallery. But somehow it won, and the BSA has really transformed because of this set of spatial relationships. So the stair is made super thin. It becomes the ceiling, which then has the infrastructure for all the exhibitions in terms of lighting and tracks to hang work. And we thought it was important to have the gallery on the perimeter so you could always be aware that what was happening and being exhibited in the galleries was clearly having an impact or transformative of the urban context, or could be if people were willing to think that way. The kind of strongest element of the space was the stair to get the public up one floor. And we wanted to make it, again, paper thin, and use that surface as a mediated surface. And so here, this is the BSA Twitter feed projected on the stair to kind of draw people in. So this notion of communication, I think, is very important in the public sphere. And I think, as you can see in my work, I often use light because I think light is communicative, and I love this, if one, if by land, two, if by sea, that very simple on-off can actually have a powerful, powerful message. A few years ago, I was asked by the General Service Administration to create a light installation at the U.S.-Mexico border in San Ysidro. It's the largest land port in the United States, and they were making it even larger. Apparently, it could take up to 6 hours to cross this border by car. So they were expanding the lanes to 27 lanes, and this is designed by Miller Hull. And I was asked to create some art here. And I was like, okay, what do I do? There's really no site, and I really, so I decided to be very minimal and almost minimal and integral with the piece. So it's called Double Horizon, and all I did was create a linear light fixture, essentially, under the canopy. But the light fixture, what it does is it basically real-time shows the movement of cars through these multiple security checks as they go through. And so this drawing shows that, there's, I don't know how many sensors there are, but there are over 30 sensors for every car in terms of the things that are being measured and scanned and weighed as every vehicle goes through. So the piece was very simple, that there would be a kind of flicker of light every time a car passed through the security check, that light would kind of flicker outwards, and as other cars move through the 28 lanes, that it would also create a kind of moment and a ripple, and then these would interface with each other. Very simple idea. Really hard to do at the U.S. border between, because of all the issues of security. And so even though there are so many sensors and all of this data is being recorded, we were unable to access or tap into any data. And in fact, they wouldn't even allow us to run our fiber optic cable in the same conduit as the other fiber optic cable for fear of adjacency. So we had to do a workaround, which basically is able to, without tapping into their infrastructure or information, know when a light is switching from red to green or when there's a change in current. And we tap into that information in order to create Double Horizon. So this is one evening a few months ago. You can see the light rippling through, and you can see this pretty far back, and something to pass the time as your 6-hour wait has been reduced to now about 40 minutes. So this idea of data and public space, I think, is really a new field. And recently I was asked to do a sculpture for Dudley Square in Roxbury in front of a new building for public education. And the sculpture is, very literally a sculpture. But what we wanted it to do was actually reflect the citizens' engagement with the city. So Boston has been pretty innovative with new urban mechanics, and they have an app called Citizens Connect where you can take a picture of a pothole and report it, and take a picture of a broken sign and report it, or note when there's trash removal that needs to be done. Very, very banal stuff. But I think what's so interesting about it is it's a direct communication feed between the citizens and the city has to respond back or take action within a certain duration of time. So the sculptural piece, which is a kind of unrolled map of the city of Boston with the different neighborhoods, is recording in real time and playing back all the reports made through Citizens Connect to the city. And each of them are tagged in terms of what kind of report is made, how the city is responding, and as those tickets are essentially closed out, the light begins to fade. And what's interesting is you see that certain areas are clearly more app used. There are more app users, and it reflects the demographic of the city as well. So you see a difference between the affluent areas and the less affluent areas in the city, which I think is important to register back to the city and its citizens. And so this is a kind of simulation of the piece, and it's currently under construction. So the other thing about public space, I alluded to it earlier, is the rules of engagement and questions we put out there. So, my husband's actually a little bit germophobic, and so he won't touch anything in public space, like a subway. He won't grab onto the bar and these kinds of things. And I was curious, will people touch things in public space? So we were asked to do a project in Dubai, and again, it was a sound installation, and we were asked if we could do something with bird songs, so sure. But for me, what was interesting to test in this piece, which is in a mall, is will people want to touch a urban instrument? So the piece is basically a series of light poles with capacitance, and it's all handmade, and a speaker, and then this is a little cone that helps to diffuse the sound through the pole. And you can see if people want to touch things in public space. So you can, based on your gesture, you can throw light in different directions. You can, see, they touch things in public space. And the goal was to create a something that the kids would touch, that the adults would touch, that people would feel like they could play this thing in public space and really interact with it regardless of age. And he's really, really enjoying that. Yeah. So that was a little experiment in terms of capacitance, but also gesture, and if people would intuitively know that you could throw light in either direction. And it was clear, people tapped it, but it wasn't fully engaging. And recently we finished a project called Swing Time in Boston. And we thought it would be important they wanted to create an installation that really engaged the public, that would be playful, and we thought it would be interesting to take on something pretty familiar, like a tire swing, something very summer fun, and make it both defamiliar and refamiliar at the same time. So the idea was to create this mega swing set that was interactive, that basically responded to people in terms of the angle in which they swung. Here's a short clip about that. You can see being alone. It's really lovely when you're by yourself. Mm-hmm. So it's a very low-tech kind of project. It's a temporary installation, so there's a accelerometer, and depending on the angle that you swing, the light changes to reward you for the higher you go. And we wanted the swing set, even in terms of the structure, to seem somewhat familiar but out of scale, so that as an adult you feel like a kid again in terms of scale. And then this year we added solar panels to it, so it's completely off-grid and powered by the sun. And so recently it opened. The opening event had 3,000 people. It was very well loved. And in fact, the client was telling us it's being loved to death, in that people are using it so much that it is breaking constantly. So we were asked to make a sign about what is allowed and what is not allowed on the swing, and we put these signs everywhere. But despite all the signage, they're used by the public the way the public wants to use them. So the other great addition to this installation is there's a bar right next door, and this public park allows drinking in public space. And so alcohol, swings, you kind of get it, right? So this is a collection of some of our kind of favorite images. People love to take selfies on it. People do strange things. People are not supposed to stand on it. And of course, I love it that people make out in the swings. So it's a swing for one and for two. It makes adults play. You can play alone, you can play together. But I think going back to the items on the list about interactive public space, it's got to be fun. It's not often that you get to think about public space, fun, playfulness in terms of architecture, but we were recently asked to design the first circus conservatory in America. This will be built in Portland, Maine. And we were looking at these old archival documents trying to explain the circus. And these like hybrid words that they would use to explain it. And we love this idea of hybridity, which I think is present in many of our projects, but how to bring this kind of notion to the design of the circus and what you could put together to create the new Cirque Conservatorium. So the Circus Conservatory of America will be part classroom. It'll be training for higher education. So it'll be the first bachelor's degree granting circus conservatory in the United States. But in addition to the classroom, it has this training room. And so the client came to us actually with this beautiful sketch from The Little Prince of the Hat Elephant. And asked us if we could design a circus around that notion. So one of the first things we learned is there's this interesting metric, even in Cirque du Soleil today, based on this 42-foot diameter circle. And that diameter is actually based on the perfect radius a horse can run around in a circle. And that has determined, a certain realm of performance arts for hundreds of years. So we wanted to bring the circus, the elephant, the hat together, and we started designing all kinds of things, and just crazy, but when you're trying to design something with the goal of just difference, it's very hard to latch onto something. So we went back to the kind of clarity of the hybrid between training and education. And this is the site, Thompson's Point. And basically, we took these kind of rigid program elements, and instead of forcing a circle geometry, we actually just put them in the round, literally with each other. This essentially allowed us to take the big training volumes, to lift them up in space in the round, to give them these amazing views out on Thompson Point, so that when you're in the practice room, you have this incredible vista outwards, but also allow them to look inward through the kind of public shared space at each other, similar to this layering that's in Tricia Brown's work. So it has both an inward and outward focus, and then we stitch those training spaces together to create these in-between public spaces that weren't really for any prescriptive use, which we think is really important to generating kind of grassroots publicness. And then by lifting the Circus Conservatory up, we allow for the public to actually move in and under the school for the performances. And the last project I wanted to share is about public space and memory. This is a memorial to Sean Collier, who was an officer who was shot immediately following the Boston Marathon bombings on MIT's campus. And designing a memorial in present day when we have, we're saturated by digital media, it was a challenge to design this memorial. And I remember seeing this sign as I went into the Boston Tunnel, and I thought it was really powerful and amazing, but it was fleeting. It was like a flicker, and it was gone. After Sean died, there were many temporary memorials that popped up along the city, and then also on the site where he was shot and killed. And after his death, at the 1-year anniversary, there was this incredible outpouring from the MIT community, and this notion of MIT Strong was very, very present, and also this term mens et manus, mind and hand, and strength. So when I was asked by the MIT committee to design this memorial, I had a lot of reservations. You know, I'm not sure I'm the right person for this. It has to deal with metaphor and meaning, which is, you know, very uncomfortable for an architect to deal with in this contemporary day and age. But I said I would try. And so the first idea was simply to deal with this notion of hand and mind. The committee really wanted it to be very of MIT. So maybe you could take the open hand and turn it into a structure. They also did something very MIT in that they created an open call to the whole community. And everybody submitted different ideas of what the memorial could be. And my job essentially was to synthesize these different ideas. One that kept reappearing was that of the cairn, the kind of stacking of boulders because of Sean's love of hiking and the outdoors, the notion of the forest. A lot of people wanted an American flag on the site. And the challenge was how to bring all of these together so it wasn't an aggregate of these different ideas, but try to find the essence of what people were really struggling with. And I remember thinking about the simple star at the CIA for unnamed agents who are killed in the line of duty. And so that was a way, a five-pointed figure was a way to address this issue of the American flag without a literal American flag there. So this is where Sean was shot. It's between the Stata and the Koch building, two very massive, iconic, at least the Stata by Frank Gehry, iconic buildings. And so the committee really wanted the site to be very close to that location. So remember this X. So we took this planted area and turned that essentially into the site. I mentioned the five-pointed figure. The idea was to take a void out of that figure, and that Boolean or that absence would always be present as that kind of figure of the cairn or the figure that was missing, the loss of Sean Collier. The other thing about the five fingers is that it allows us to create multiple spaces and create a really porous memorial. So it's not purely a wall, but it's a threshold, it's a gateway, it's a space, and reminds people that MIT's campus is an open campus, and we're not going to close and make artificial gates, etc., but to celebrate that openness, but to create a kind of moment of pause within that gateway into campus. Then the other thing that was constantly in my mind were these Inca walls that were made out of massive, massive blocks of stone, each completely unique and doing exactly what it needs to do structurally. So the idea for how to build the memorial came from thinking of every piece as coming together. There are 32 of these large blocks that essentially come together to create a vault, a five-walled vault, and that's the keystone in the middle. So it uses pure physics and geometry. There's redundancy in it, so you can even remove a block and the loads span. And so it was important that we do this with that level of integrity and literalness. The first meeting with the structural engineer, they said, oh, you can cast it out of concrete and clad it in stone. Actually, that's what the contractor said. The engineer wanted to post-tension it, to put a lot of steel in it. And we insisted that we wanted this absolutely flattest possible dome, but built using these ancient techniques of the Incas. In order to do that, we had to build in the ability to calculate the forces as we were designing the geometry. So we made a design tool, or our engineers helped us develop this design tool that enabled us to kind of calculate the load every time we dealt with a wall. And so here you can see when the forces go outside that wall, basically it won't stand. So the thrust line has to resolve itself within the kind of third point of the wall, otherwise it doesn't work. So that led to many iterations of different geometries that could work. And the final geometry was one that creates a window between two of the walls that are closest together to the actual spot where Sean was killed. Each of these pieces is unique and comes apart. There are small pins, steel pins that help with the alignment and placing them together, and then do some structural work in lateral movement for an earthquake. So each of those blocks came from a quarry in Virginia. This is the Jet Miss Quarry. And one of the things that I learned that was shocking was that these quarries have only a 15% recovery rate, right? So that means 85% is thrown away, which if you go, it's just from a material point of view, this was astonishing. So one of the things, and it's because there's tiny cracks and little green veins and these kinds of things that make them not perfect for kitchen counters, but for us, they were perfect. Every block could be used because we had such unique blocks. And so we would go hang out with giant rocks with our laptops and try to figure out how to three-dimensionally carve these pieces out of these blocks. So there are some massive saws to do that. We used computer numerically controlled saws and robot arms, and the project was really one of subtraction. So from the first loss of the Boolean operation in the figured structure to the kind of removal of material and the carving of each of these individual blocks. The texture is kind of amazing, and but you can see the blade sometimes is going cutting and then sometimes going cross grain, and so it's essentially scraping material off the blocks as it gets finer and finer in terms of that surface. So what was very important about the project was that the geometry was, because we wanted it to work through geometry and physics and not through post-tensioning or steel, it meant that the tolerance issues were absolutely tight, that we could not be more than 2 millimeters off in any direction for the geometry to work. And we thought that was fine because, we have computer numerically controlled saws and robot arms and, computational tools, and it'll be fine. But the problem was you need material to remove material. And so the saw blades, as they were cutting, so some of these blocks took 24 hours a day over 7 days. So they were running 3 shifts just to carve sometimes one block. And so over that duration, the blade itself would wear. And there was no way to calculate how much the blade would wear over how much time. So we were getting blocks that did have millimeters of difference. And so as each block was completed, they were measured. These were then registered with the exact dimensions, and then we would compare with our computer file and decide whether to make an adjustment in the next block or not. In addition to that, the structure, because of its massive weight, it's 140 tons, it sits on 33 mini piles that go between 30 and 45 feet below grade. And that site I showed you at the very beginning between the Stata and the Koch, apparently that's where all the power to MIT comes through. And it comes through this duct. So we had to be very careful to span and not, have any of this massive load compress on the duct itself. There's the keystone. There's a shelf in the keystone. It doesn't have any pins, just pure geometry and gravity. They brought every block one by one as it was fabricated. It was then shipped to the site and puzzle pieced together. And it was built inside out. So we started with the keystone, which is kind of reverse of how you would think of doing it. And there was a temporary scaffold in place. That temporary scaffold was there so that when we lowered the scaffold, we would know how much the blocks moved and whether our calculations and our engineers' calculations were correct. So there were strain gauges put in every crack, and there were weights, these massive scales, put under the scaffold. To make sure that as the scaffold was being lowered, so there was a little dial on each one where we could lower it, micrometer by micrometer, essentially, and then just make sure that the loads and the thrust lines were behaving as we expected. And so these were being registered, and it worked. And the construction team felt comfortable standing under it, which they were very worried to do all along. And the last element of the design piece has again to do with memory and time, and that was how to inscribe not permanence on the site of this public space, but this notion of a kind of single moment in time, the time he was shot. So what we did was we took the constellation of stars the night Sean was shot. So if he looked up, this is the constellation he would see, and we put those constellations in the ground plane. He was 27, so there's 27 points of light, and this is the kind of first night that it opened. So it's become a public space at MIT, and as a memorial, of course, there is a sense of somberness and pause as you move through that arch or vault underneath. This is the portal that's the window to where he was shot. There's raised lettering to prevent the skateboarders from going up on the edge. But really the memorial frames many of these moments, but it also creates a kind of openness on campus. And there's a beautiful quote by his brother, who was also the project manager on site. Live long like you would, big hearts, big smiles, big service, all love. And I think for me, it's been really interesting to see how loved this memorial has become within the public space of MIT. And you see crazy stuff. You see kids sliding down this, sliding down the curve. I'm waiting for the MIT hack where there'll probably be a football team standing on top of the memorial. But I think for me, what was very critical and eye-opening was that now that it is in the public sphere, it's no longer mine, and the public's.
Which are kind of interesting, but one of them, I think, in the seminar, fabrication seminar, you showed the MIT memorial fabrication of it, but she gives much more background to it. It's kind of interesting, very interesting process. But we have to move on. These adaptive and interactive installations, which she excels in, are really worth to pursue. They're on the border of architecture. There are few projects architectural. And as you've seen, the familiar project of Athens Olympics was really what made her into household name. Her work is interesting because she not only conceive conceptually and enters this public realm, but also programs it and closely relates to act of fabrication. So her designer role is redefined. I want to signal the forthcoming book, which is not yet out, but I was reading drafts of it. It's called Interactive Architecture, Adaptive World, and this propose how observations and information process utilize tools to translate natural systems and translate them seamlessly into integrated environments. So this is somewhat similar to ideologically to what Meiji Nyun was talking about, but this is an encyclopedic type of work which overview a lot of recent projects with kinetic facades, performative materials, and adaptive buildings and installations. What is interesting to me from this particular author was that he coined a new notion of biorobotic architecture, which he defines as architecture that goes beyond mere capacity to interact. It defines a word that repositions the role of designer as a catalyst of design that can adapt and evolve with world around it. It lies on intersection of biology and robotics. It hinges on a unique area of naturally inspired and robotically augmented designs. As the term adaptive has increasingly fostered a shift from paradigm of mechanical to biological. It has left a gap in the area of control, and robotics help to fill this gap in a strictly biomimetic approach to architectural design. So that brings me to this third word in the title of a lecture, which is biomimetics, I guess. Building Dynamics is another publication which is recent and just out, exploring the architecture of change. I have few projects. Some of them are discussed in this publication, which I would like to relate you to. You might see some fragments of the publication, but it's good to get close to it. One is projects by, I think it was Cloud 8, maybe not Cloud 9, but maybe Cloud 9. It's Barcelona firm. The lead art designer is Enrique Ruiz Gelli, and he proposed the project, which is unbuilt actually, but this we called Urban Forest Project, which was actually stainless steel mesh, tensegrity mesh wrapped over an entire building, which was rather conventional. But this was a structure or armature for 5,000 artificial leaves and sealed discs that contain photovoltaic cell, the battery, tiny CPU, and 3-color light-emitting diode. Together, they work together yet independently from each other. That's important. Each leaf absorbs energy and converts it during the day into stored power. which is controlled by CPU and powers LED at night. Depending on how much light is absorbed, CPU calculates response as to the color. The color of hotel at night in the summer, for example, will be different than in the winter. Building acts as a form of thermometer, replaying earlier condition of heat in midsummer night during the evening. Each leaf is independent, yet interacts similarly through a shared set of environmental circumstances. Electronics, therefore, are as simple as possible. Functioning as skin, leaves offer sizable reduction in air conditioning loads. So this analogy, a direct analogy from through a point cloud from nature to the man-made object is, I guess, what this building can be described as. Here are a few images from this project. I think I have a clip from designer's lecture, which I want to leave some time for. So, okay, well, this is the project. Or maybe he has. His clip is later. Okay, yeah. Then this is urban forest, and a second project of his, which has been built 2 years ago. You probably have seen it as well. It's called not Mediatek but Mediatik, and the project relies on Arduino-based network that connects hundreds of sensors that measure sun and heat angle and modify characteristics of ETF cushions. So the nature of envelope is changing, responding to sun condition, becomes more opaque, and building is kind of symbol of energy efficiency. They claim very big reduction of and energy savings and being close to net zero footprint. The facade is dynamic, and air cushions form pneumatic shading. There are 3 layers of those cushions of plastics, and when those cushions are inflated and deflated, the opacity of the envelope is modified. This concept of networked series of Arduinos and modification of the environmental envelope is important. And theoretically, he claims that he says that if we knew how nature performs about its science formulas, inputs and outputs, we would have parametric system, architecture from information, parametric architecture capable of dealing with its own complexity. But maybe it is dead or programmed but not activated. We need, just as in nature, logic with blurred, vague boundaries that function as randomly and as chaotically as particles or at random. We need creative rhythm to produce certain accident. He proposed notion of particles architecture, which is very interesting and original, and this is characterized in his most recent work, which is not yet built. But I want to leave a little bit for his lecture. From IAC, it's probably 2 years old.
Going to Figueras, 4 trees, 4 structures, 4 skin, 4 energy, habitants, inside temperature, waterproof, shadow functions, energy flow. It's a building. These are 9,000 leaves working together. area. It's architecture of indetermination. It's a forest. It's collecting energy day and it's burning every energy by night. It's self-sufficient, charges and burns, charges and burns. But at the same time communicates the neighbors, what is it? In fact, there is energy in the south, west, east, north. Energy is around us. And every day is different. So every night, the building tells the community what energy was produced as a diagram. But what is that particle? What is that leaf? We have a small computer, Arduino today, a PV cell that produces energy, that moves the energy to the battery, and a sensor that tells the computer it's the night. The computer asks the battery every night, how was the day? And the battery, you know, it's been shadow 10%. And the computer asks the architect, what did you tell me to do? Well, just burn the energy using the red LED. And I did it. So every day and every night, the sensor tells it's the night. The computer charges and looks for the battery. What was the day? The day was sunny. The day was 100%, fully charged. Okay, what the architect told me to do? Burn that energy. 3 LEDs, white light. That's the prototype we have been working on with Igusini. It's self-sufficient, no cables, no data, no network, no hierarchy, no IP, no control over it. This is the model we did. We spent about 4 months to do this model. My students, good luck with the model. Yeah, okay? So, what was about the liquid? Remember we were talking about that liquid? The fact is that I have to do something really good in Figueras. Maybe I get a chance to do something good in Girona. Maybe I have a chance to meet my people in Manresa, if that is good. And at the end of my life, of my career, I will be successful in Barcelona. But the dream was Paris. That was the vertical hierarchy that we are used to in other generations. Today, I do something really good in Figueras. This model belongs to MoMA, New York. Okay? It's flat. It's a liquid. We are together. No folders. Good news. So that's how it looks by night. That's the performance. So that's what the neighbors get.
Okay, so I guess the keywords which I use in this presentation are on the screen. I think that we broadening the or erasing the boundary or eradicating the boundary between categories, and we see the importance of parametric design as a generative tool, but it is extended through act of making and through act of responsive or adaptive or dynamic or kinematic architecture assisted by the robotics as a kind of area of concentration and future potential. So the even superficial engagement into series of those domains, I think, will be of a direct relevance to your future creative pursuits. Okay, thank you.